So before getting to the tertiary stuff, I want to let you know that I went back and organized all these nodes. We are getting to the point where our network is fairly large, so it makes sense to section things off, type out what you're trying to do. If there is a wrangle like this, it's really important to name that wrangle. So in this case, getting the normal or randomizing the size and the variant, just so that if you ever go back, you're like, oh yeah, that's what I was trying to do with that wrangle. It's getting to the point where you'll easily forget. So go ahead and do that if you haven't yet. I like just making these little boxes and just titling them for what that section's trying to do. And now, as you can see, I've made room for the tertiary stuff. And specifically, be sure that we're doing this tertiary stuff after we've created that secondary name suffix. So after this guy. In other words, our name is all taken care of. Now it's time to move on to the tertiary after we've gotten done with the secondary. So before we start dropping down nodes, let me give you an idea of what I'm trying to accomplish here. So let's say that I have a secondary piece. I'm going to draw a beautiful rock here. Let's say that I have a rock and it looks something like that. This whole thing is secondary in scale, and I want to be sure to keep it that way. Well, we know that it's not going to be a good idea to just scatter a bunch of points on here and spawn things to Boolean, because that's going to chop up the secondary piece in all kinds of different little pieces, and we no longer have a secondary piece. It ends up being just a bunch of tertiary stuff. So that's not going to work. We can't just scatter points onto a secondary piece. Again, or even a Voronoi fracture, because it'll just, break this up so small that it's not secondary anymore. Instead, what we need to do is we need to isolate the edges of the secondary piece. Let's say areas like this, and we need to break them off. Okay? If we find a way to isolate points to, let's say, the edges here, we can do something with that. We can chip them off, and we can keep our secondary scale intact. So that's what we're trying to do. Now, how might you go about this sort of thing? There are a couple ways of doing this. My favorite method is something that I came up with. It looks something like this. We start off with a bounding sphere over the whole thing, right? And then we take that bounding sphere and we bring it in. So by doing that, we now have a sphere that, let's say, might look something like this. And maybe you could see where I'm going with this. Because we have brought in the sphere, now we have the ability to just group out only the points that are along the edges like this. So we've isolated everything that is extraneous from the main secondary piece. That's the first step. So we isolate these little edge areas. Once we do that, the next step here is to scatter some points along these edges and to spawn something to Boolean against the secondary piece. So let's say that I have another rock over here ready to go. Now, let's say that I scatter 2 points along the geo here that's on the edge. I can just take that rock, bring it on over, and use it to chip away at just that little corner section, leaving us with a cool situation where we've chipped away at the secondary piece along the corner. We still have our main scale intact, but we've now broken off a tertiary sized piece, and we are good to go. That's my crude illustration for what's going on in my head. I just want to let you know what my thinking is, though, before I start laying down notes, because I think that'll help you understand where I'm going. So back here in the network, I'm going to press Control B to make this full screen, because we don't always need to see that viewport, and I figure it's nicer for you guys to look at sometimes. So from now on, I'll do that. But anyway, we now are at the end of our secondary fracture. Let's see what we have to work with before we get going. We have that name, but it's not lining up with the prim attribute. So first things first, attrib promotes the name. We want the name to be the same for points and primitives. Again, name is going to be the thing that messes you up. Guaranteed. So be sure that that doesn't happen to you. Also, don't delete the original. So that name now exists as a points and primitive. They're the same thing. Life is good. After this, we know that we just did a secondary fracture and our geo has a bunch of n-gons because of that. So let's use a divide SOP to prevent any n-gons from existing. And that's just a good idea because you never want a Boolean against an n-gon. Okay, so there's that divide. I guess you could Boolean, by the way, against an n-gon. It might work for you, but I just like to not go there if I can. Anyway, now that we have that set up, let's take a look at our for each named primitive loop. First things first, we want to only isolate the big pieces. So we're going to use a split SOP, and we're also going to use a measure SOP. I'm going to put that measure in the loop because that'll help it go faster once this is all compiled. So for that measure, again, we want the area per piece, and our piece attribute is called name. Easy as that. Now on this splits, we need to use that area. So we'll say at area, if that is greater than, let's say a value of 0.1, then go ahead and go with that left inputs. I'll create some nulls so that we can mark this too. So we'll say larger pieces, and over here, we're going to have our smaller pieces. Let's be sure that we have this right before we move on with everything. So at the very end of that for each, we'll set the visibility, bring back our viewports, let that cook here for a second. And it looks like we are preserving the bigger pieces. Let's actually put the visibility down here as we do that and just kind of connect it like so. Because it has to rerun everything. It'll just do one piece. Yeah, okay, so there we go. We're ignoring all of these smaller pieces, and that's good. Now we just have the big pieces. Okay, now that we have that, let's go ahead, bring back our full screen so our viewport doesn't try to cook as we do this. For those larger pieces, like I said, we want to start with a bounding sphere. So we can do that with the bound SOP. That will create a sphere around each one of these large pieces, especially if we set it to sphere right there. And we also want to check on this accurate bounds. So now if we look here in our viewport, let's actually go to that for each end, set this to single pass $f, and see what we can do. Okay, let's find ourselves a good piece. That actually looks like a beautiful rock. So let's use this as an example. Again, we just created a bound. Middle mouse, this is a sphere primitive type. We want to convert that though to polygons because polygons are a lot more useful to what we're trying to do. Down here, if we go to divisions per span, we could set that to, let's say, 3, and that should be enough for what we need. Okay, so we have, let's say, the bounding sphere right here. There's a larger piece. We're trying to get these edge areas, right? So we need to bring that sphere inwards a little bit, and by doing so, that will isolate the points that are along here. Luckily, we have the peak SOP to do exactly that. So let's say that we use this peak SOP now to bring this in by negative points, maybe 0.03, something very, very tiny. Okay, we brought that in. We now need to use this to group things. There's a group SOP, ready to go. We're grouping the larger pieces, and we want to use this as our bounds. So let's call this our points inside bounds. Okay, check off the base group, keep in bounding regions, bounding object, and we need to group points $OS. Now that we have that, there we go. As you can see, we've grouped all the points that are inside that sphere, which we can now use to, let's say, blast anything that that group found. So points inside bounds, Control C, paste it in there. We're looking at points. Now we just have these little slivers of geometry left over. And that's good because this is going to serve as the perfect basis for a scatter. On that scatter, I want to set the force total count to 1 for the time being. You could use 2 if you want. Sometimes you might get this though, where you have 2 points right next to each other. So up to you if you want to do that. It's not a huge deal if that happens. You might get some messy booleans though. So just to think ahead and prevent that situation, let's just say 1 for right now. The next thing we need is some geometry to spawn onto that point. So I'm going to create a labs sphere generator. It's a nice little quad sphere. And let's also go ahead, clean up any attributes because the labs does come with some weird Maya attribute things. So we do have that just position now. And so that's good. Let's also go ahead and use a mountain sop and just kind of mess around a little bit with this. Element size 0.25, height 0.15, and maybe do a whirly cellular, something like that. The reason why I'm using a sphere and not a scanned rock is because at the tertiary scale, you're not going to see all that detail. We want to keep these polygons fairly coarse because if I go to this sphere and I set this to like 5 or something like that, you're never going to see this detail. It's just adding a bunch of polygons. It's really unnecessary and it slows the whole thing down. So none of that is good. We want to keep this fairly coarse. And so this is going to work perfectly for what we need. Okay, in the next video, let's copy this over. We'll compile the whole loop and situate the name attribute.